All right, hi class. Today we are going to be looking at lesson 2-4. We're going to use constant and proportionality to write equations that represent proportional relationships. So this is a key concept for today. And we're going to use equations to solve problems that involve proportional relationships, all right? So constant value, often write K, can relate the amount of the rise and fall uniformly together. So the ratio of the amounts is y and x. So typically we write it as k equals y over x, or you could think of it as k equals y over x. And we can write the equation in terms of y as y equals k. If you multiplied both sides by x here, you would have y equals k. So our constant of proportionality is y equals kx. This is our equation, okay? So we want to write an equation to represent the proportional relationship here. So a sponge is an example of a filter feeder. It takes food in by filtering water through its body. So the water goes in and then out comes the waste maybe, right? So the sponge maintains a constant flow of water through its body. What is an equation that represents the proportional relationship between the time and the amount of water filtered? So we can write this out as a table as x and y. And typically, time will always be x. Time will be x. Okay, so just remember that time is x. Think of it as time. So this will be the hours, and y will be the liters. So if 10 liters go in, what comes out? 8 liters come out. If 15 liters go in, how much water is coming out? 15 liters are going in, only 12 liters come out, okay? So we can use this, we can write this out. It says write a proportional relationship between the two. So we can have k equals y over x. So we will have k equals 8 over 10. And if you simplify that, that is 0.8. If you took k equals 12 over 15, type that in your calculator, you will also get 0.8. They are the same. They are proportional, okay? Since these are the same. Since they are the same, this is what k equals. K equals 0.8. So our equation, it's asking us for an equation. What is an equation for this? Well, our equation for constant proportionality is y equals kx. We know what k is. So our equation is y equals 0.8x. That is our equation. All right, the next question. Yep, that's the bottom of the page. Marie made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used in each batch. Write an equation that relates the proportional quantities. So we have x and y, so it would be 8 over 5. And you can type this in your calculator. 8 over 5 is 1.6. Or we could have 16 over 10, which is also 1.6. So k equals 1.6 because they are the same. Okay? So the constant of proportionality is a fancy way of saying what is k? K is 1.6. So an equation that represents the proportional relationship. Go ahead and type that in, Edpuzzle. It is y equals 1.6x. That is our equation. All right, solving a problem using an equation. 1 inch equals 2.54 centimeters. So we can see that here. How many centimeters long is an 18-inch ruler? Well, we know that we could just take 2.54 times 18, and that would give us our answer. But it's asking for an equation here. So we need to think about what is going in. Well, if we have the number of, what is K? It's going up by, so we have to think, what is K? What is K? All right, K means it is going up by 2.54 centimeters per inch. So that is our K. Well, we know the equation is y equals 2.54x, where x can be our inches and y will be our centimeters. So our equation is y equals 2.54x, so we have y equals 2.54 times 18. And look, that is what we had here with intuition. We knew that we just multiplied the two, but we're trying to make that connection with direct variation, okay? So we have y equals, when you multiply the two out, you will get 45.72 centimeters. So go ahead and try this one on your own. You should have gotten y equals 2.95x. So you'll have $53.10. Okay? Example 3. Can you represent the total cost y for the admission x rides at the amusement park using the equation y equals kx and explain? Okay? So the admission is $20. After we go into the park, we then pay $5 for each ride. Well, let's think, how much would it cost? We have rides. We'll make a table here, and the cost. If we rode 0 rides, but we decided to go into the fun fair, but then we're like, oh, they're all too scary. Well, we've already paid to go in, so the cost would be $20. If we go in and ride 1 ride, it would be $5 for the ride plus the 20, so it would cost you $25. If we rode 2 rides, it would be $30. 2 times 5 gives us the 10 plus the $20 in. 3 rides would be $35. So we can see it's going up by $5 each time. But the question is asking us, is there a, can we represent this using y equals kx? So what is k? Well, let's look at k here. K would be equal to 25 over 1. So that would be 25. In this case, k would be 30 over 2, which would be 15. In this case, k would be 35 over 3. So that is about 11.67. Are these the same? Not the same. They're not the same. So our k is not constant. It's different. So can we write this out using this form? No, we can't. No, we can't use y equals kx. And what we want to say, it is not proportional. Proportional. Okay, so they are not proportional. All right, our last example here. Balloon A is released 5 feet above the ground. Balloon B is released at ground level. Both balloons ride at a constant rate, meaning constant means they do not change. Which situation can you represent using an equation in the form y equals kx? So if we had this one, it would be 9 over 1, which is 9. In this case, it would be 13 over, I'm going to rewrite this down here actually. 13 over 2, which would be 6.5. And this one would be 17 over 3, which would be 17 over 3. 17 over 3 is about 5.66. So is this constant? No, this is not constant. Okay, there's not a constant rate. Well, let's look at this one. 4 over 1 would be 4. 8 over, that's a 4. 8 over 2 would be 4. 12 over 3 would be 4. So balloon B balloon B has a constant rate of 4, right? Because K is equal to 4. So we can write this equation as y equals 4x. All right? This is a new concept for us. We're looking at how to write equations in linear form. This might be a lot for us. So write down any questions you may have. I hope some of this was able to sink in. I will see you all on Zoom. Have a great day.